This is an experimental kit to find Planck's constant using LED. The circuit connection done over here is shown in the manual. There are 4 types of different LEDs given: blue, green, yellow and red, and the wavelengths are mentioned. This is the theory part along with all the formulas, and this is the circuit diagram. This is the voltmeter having 2 ranges, 200 millivolt and 20 volt, and this is our ammeter having 2 ranges, 200 microampere and 20 milliampere. So this is the 0 to 5 volt DC supply. So we'll switch on the kit. Make sure that these are at the minimum position before switching on. Now there are 3 ways of finding out the Planck's constant. In the procedure, it has been mentioned very nicely what are the different ways. One way is that you take the voltage when the LED just starts to glow and calculate by using this formula. Another method of finding the Planck's constant is by plotting the IV characteristics of the LED, different IV characteristics, and from there finding out the threshold voltage, which are given here in bold. And from the threshold voltage you calculate the Planck's constant. And finally, the third method is by plotting the 1/, wavelength versus voltage curve and finding out the Planck's constant from the slope of the curve. All the calculations have been done here in details along with the percentage error for all the 3 methods. So let us just see what is the value for currently blue LED has been connected. So I'm increasing the voltage. Zoom in this. Change it to 200 microampere for measuring the current when it just starts to glow. So it starts to glow now. So it is at 2.5 volt or 2.49 or 2.5 volt, and the current is 3.5 microampere. Okay. Make the 0 and now move on to the next one, that is green. Again zoom into the green one and we will see what is the voltage when the LED just starts to glow. It has just started to glow. So the current, 1 second, 21, yeah, it's glowing, right? Yeah. So the voltage is around 2.20 voltage. Current is 45 microampere. And for the yellow LED, so it has started to glow. So the voltage here is 1.92 volt and the current is 4.5 microampere. And for the red LED, the voltage when the LED just starts to glow, it has just started to glow, so it is coming, the voltage is coming to be 1.78 voltage and the current is 2.2 microampere. So similarly, you can take the value of voltage versus current characteristics. For that, change this to the 20 milliampere range and start to increase the voltage and take down the reading for the corresponding amount of current. Initially take for very small variation of current like 0.1, 0.2, 0.5 milliampere, and then take a little bit more like 1, 1.2, 1.4, 1.5, 2 milliampere. Plot the characteristics and find out the Planck's constant from that. As you can see here, we have got pretty good results. From the threshold voltage when the LED just starts to glow, our calculated Planck's constant is 6.3 into 10 to the power of minus 34 joules per second. and error is coming out to 4.97. You can also calculate this for individual LEDs. And from the threshold of the knee voltage from the graph, IV characteristic graph, the calculated value is coming to be 7.28 into 10 to the power of minus 34 joule second, and the percentage error is 9.8%. You can also do this for individual LEDs. And from the slope of voltage versus 1 by wavelength, we are getting 6.32 into 10 to the power of minus 34 joule second, and the error is only 4.6%. So this concludes our experiment.
Please subscribe to our channel for more such videos. Thank you for watching.